Hi 8th grade, this is Miss B here with lesson 6.8, and today we're going to continue simplifying radical expressions and solving problems using the Pythagorean theorem. So let's begin by going over our do now. In our do now, we have three radical numbers that we are to put in simplest radical form. That doesn't mean that we're substituting into the calculator and rounding to a given decimal value. We're going to break these numbers down and try to still keep the radical if it's not a perfect square number. So let's recall the first 10 perfect square numbers. You do have your reference sheet to help you today, but for the do now and for the purpose of this video, I'm going to go on ahead and list them out. So we have 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 4 squared is 16, 25, 36, 49, 8 times 8 is 64, 9 times 9 is 81, and finally we have 100. So what we're going to want to do now is rewrite 48, the square root of 48, as two factors in which one of them is a perfect square number. So some of you might have noticed right away just by looking at our list, 4 is a factor of 48, 16 is a factor of 48. If you're not able to see that, one thing that we talked about doing was actually listing out all the factors of the number that you are simplifying. So for example, the factors of 48 are 1 and 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. So if we look at our list of factors, you'll notice that 4 is a perfect square number and 16 is a perfect square number. So I'm going to go over this example by using both of these factors. So let's get this out of the way here. So let's use 4 and 12. So if we have the square root of 4 times 12, so all we've done right now is rewrite 48 as the product of 4 and 12. We can then separate this into the square root of 4 times the square root of 12. And now we're going to take the square root of the perfect square number. The square root of 4 is 2, and 12 is an irrational number. But what you'll notice is that 12, the square root of 12, is not in simplest form. The factors of 12 are 1 and 12, 3 and 4, well, I missed 2 and 6, and 3 and 4. So we have another perfect square number. So what we can do now is break the 12 down further. So we have the 2 as our coefficient, and we can rewrite 12 as the product of 4 times 3. So now we're going to have 2 times the square root of 4 times the square root of 3. Right? And again, we can take the square root of 4, so we'll have 2 times 2 times the square root of 3. So our final answer is 4 radical 3, right? And 3 is a prime number. Its only factors are 1 and itself. So the square root of 48 in simplest radical form is 4 radical 3. So let's use the factor of 16 and see how that's different from using 4 and 12. Sorry, I think I said 4 and 16. I meant 3 and 16. I paused the video, so I'm not really sure. But 3 and 16 are the other two factors that multiplied 48. So we have 16 times 3. And again, we can rewrite this as the product of the square root of 16 times the square root of 3. The square root of 16 simplifies to 4. And the radical 3. Again, 3 is a prime number. We can't break it down anymore. So if you notice, it was fewer steps, and we ended up with the same exact answer. So what's beneficial here is if you start factoring using the largest perfect square number. So let's take a look at the next example, the square root of 63. So looking through our list of perfect square numbers, find a factor of 63, the largest factor that you can find. Right, so we would use 9 times 7. So now we have the square root of 9 times the square root of 7. The square root of 9 is 3, and 7 is a prime number. We can't break it down anymore. So the square root of 63 in simplest radical form is 3 radical 7. And finally, the square root of 300. I know you guys get really excited when you see the hundreds because it's obvious that the largest perfect square number that will divide that is 100. So we can rewrite the square root of 300 as the product of 100 times 3. Break this up into radical 100 times radical 3. So we'll have 10 radical 3 in simplest form, all right? Make sure that you show all your work. And don't skip this middle step. Don't skip this middle step over here when we break it into 2 radicals. It's going to help if you have those bigger numbers that you need to simplify even further. So let's take a look at the guided practice for today. We're going to be doing 2 word problems together. In guided practice number 1, we have a right triangle with one leg of 2 centimeters and another leg of 6 centimeters. And we know that these two are the legs of our right triangle since the right angle is across from the unknown side, which is our hypotenuse. So as we would with any Pythagorean theorem problem, we're going to start by writing out the formula, right? So the formula, we have a squared plus b squared equals c squared. So we're going to substitute our legs. Remember, a and b are interchangeable. So we have leg squared plus the other leg squared is equal to our hypotenuse squared. 4 plus 36 is equal to c squared, which means 40 is equal to c squared, right? And if we take the square root of both sides, we have that c is equal to the square root of 40. Some of you have been skipping this step right here in your classwork last week. Do not skip this step, especially because what we're going to be doing, and you have to read the question carefully. If it says simplify your answer, you're simplifying to its to the simplest radical form. You're not plugging this into your calculator and writing to a decimal. It doesn't even tell us what decimal value to round to. So now we have to use the same process that we've used in simplifying radicals. So if you look at your list of perfect square numbers, 4 times 10, where 4 is a perfect square number, is the product of 40. So now we have radical 4 times radical 10 equals c. The square root of 4 is 2. And 10, it's not a prime number, but it doesn't have a perfect square factor. So 2 radical 10 is the square root of 40 in simplest form. All right, so let's take a look at one more example before you get started on practicing on your own. Okay, in this case, we have the length of one leg. We have the length of the hypotenuse, and we must find the unknown side. In this case, it's the other leg. So let's start by writing the formula. A squared plus b squared equals c squared, and we're going to substitute our values. So for a, we have 3, so leg squared, and we're solving for the second leg, is equal to our hypotenuse squared. So let's simplify now. 3 squared is 9. B is what we're solving for, and 9 times 9 is 81. So we're going to have to use inverse operations here to get the variable that we want to solve for by itself on one side of the equal sign. 81 minus 9 is 72. Okay, so now if we take the square root of both sides, right, the square root of b squared, the square root of 72, the square root of b squared is b, and square root of 72. So 72 is not a perfect square number, but again, it says the problem is asking us to simplify our answer, so we're not putting it in and rounding to a decimal value. We're going to rewrite 72 as the product of 2 numbers, where one of them is a perfect square. So in this case, it's 36 times 2, the square root of 36 times the square root of 2. gives us 6 radical 2. Okay, so the square root of 72 in simplest form is 6 radical 2. And if you wanted to double check your answer, remember what you could do is substitute the square root of 72 into your calculator and substitute 6 times the square root of 2 into your calculator and make sure that you end up with the same exact decimal value. We're not changing the value of these numbers in any way, we're simply just writing it in a different form. So the square root of 72, rounded, let's say to the nearest hundredth, is approximately 8.49, as is 6 times radical 2. So that's one way that you can check that you've simplified correctly. So you have approximately 30 minutes to practice on your own or with a partner at your group for our morning class. Be sure to use your reference sheet and to simplify until you can't simplify that number under the radical anymore. If you need additional help, there is another video. It's marked 6.08 part 2, and in that video I'll do a few examples from the independent practice portion of your handout.